wondered if time could bend, stretch, or even run backwards? This thought-provoking question was at the heart of Albert Einstein's revolutionary theory of relativity. Einstein's work fundamentally transformed our understanding of time. He proposed that time is not a constant, rigid entity. Instead, it's a flexible, malleable dimension that can stretch and squeeze depending on the speed at which one is moving and the presence of massive objects. Imagine you're on a spaceship hurtling through space at close to the speed of light. Back on Earth, your family is having dinner. According to Einstein's theory of relativity, time would pass more slowly for you on the spaceship than for your family back on Earth. This is a phenomenon known as time dilation. Time dilation isn't just a theoretical concept, it's a proven effect of relativity. In fact, it's been tested and confirmed by many experiments. One of the most famous examples is the Hafele-Keating experiment, where atomic clocks flown on airplanes showed a different time compared to those left on the ground. This confirmed that time passes at different rates for observers in different frames of reference. But why does this matter? Well, time dilation lays the groundwork for the possibility of time travel. If time can stretch and squeeze, then it might be possible to traverse it, to move forwards or backwards through it. Of course, we're not quite there yet. The speeds and gravitational forces required to significantly dilate time are far beyond our current technological capabilities, but the fact that the laws of physics allow for it is absolutely fascinating. The theory of relativity paints a picture of a universe where time is not an absolute, unchanging river, but a dynamic and flexible dimension that can be influenced by speed and gravity. It's a radical departure from our everyday experience of time, and it opens up a whole world of exciting possibilities. So if time can stretch and squeeze, might it also be possible to traverse it? That's the tantalizing question we'll continue to explore as we delve deeper into the science behind time travel. Imagine if you could step through a door in New York and emerge in Tokyo in an instant. Welcome to the world of wormholes, hypothetical shortcuts through spacetime that could, in theory, connect distant points in the universe. Imagine folding a piece of paper in half and poking a hole through both ends, creating a direct path from one side to the other. This is the essence of a wormhole, a tunnel in the fabric of spacetime. Wormholes are a prediction of Einstein's theory of general relativity, which describes gravity as the warping of spacetime by massive objects. According to this theory, wormholes could link not only different locations in space, but also different moments in time, opening up the possibility of time travel. The concept of wormholes is not without its challenges. For one, we have yet to find any concrete evidence of their existence. Physicists are also grappling with the issue of stability. In their most basic form, wormholes are incredibly unstable, collapsing in the blink of an eye. However, some theoretical physicists suggest that exotic matter, a form of matter with negative energy density, could be used to stabilize wormholes, preventing them from collapsing and potentially making them traversable. Yet exotic matter is, well, exotic. It's highly speculative and not something we have on hand. Furthermore, even if we could stabilize a wormhole, we'd still need to figure out how to create one in the first place. And that's before we even start to consider the massive amounts of energy likely required, or the potential dangers and paradoxes that might arise from stepping through a gateway in time and space. Despite these challenges, the idea of wormholes continues to captivate scientists and the public alike. Their potential to enable instantaneous travel across the cosmos, or even to different times, is a tantalizing prospect. Wormholes might remain in the realm of theory for now, but they open up fascinating possibilities for time travel. So, while we might not be packing for a trip through a wormhole just yet, it's a journey that science and imagination continue to explore together. What if the future could affect the past? Now, that's a question that flips our usual understanding of time on its head. But in the realm of quantum mechanics, normal rules don't apply. Here, particles seemingly play a game with time, hinting at its non-linear nature. Let's delve deeper into this intriguing aspect of quantum theory. Quantum mechanics, the branch of physics dealing with the smallest particles in the universe, introduces a whole new layer of possibilities for time travel. This world is so different from our everyday reality that it often seems counterintuitive, if not downright strange. But it's within this quantum weirdness that we find hints of time's flexibility. One of the most fascinating experiments in quantum physics is the delayed choice quantum eraser. This experiment involves particles of light called photons which are fired at a beam splitter. The photons can take one of two paths, and we don't know which path they take until we observe them. Now here's where it gets really interesting. The act of observing, even after the photons have passed the beam splitter, seems to determine which path they took. In other words, it's as if our decision in the present influences the photons past. This experiment has been interpreted to suggest that particles can be influenced by future events. It's as though the future sends information back in time to the past. This idea challenges our everyday understanding of causality, where cause always precedes effect. But in the quantum world, cause and effect might not be so straightforward. This gives rise to what's known as retrocausality, the notion that an effect can occur before its cause. It's a mind-bending concept, but one that could potentially open up new possibilities for time travel. Another quantum phenomenon that hints at the flexibility of time is quantum entanglement. This is when two particles become linked in such a way that the state of one instantaneously affects the state of the other, no matter how far apart they are. Some physicists have even proposed that this instantaneous connection could be a form of time travel at the quantum level. However, these ideas are not without controversy. Quantum mechanics is a field full of debate and differing interpretations. And when it comes to time, the questions are even more profound. Does time flow in one direction, or is it flexible? Can the future really affect the past? And most importantly, what does this all mean for the possibility of time travel? We don't have all the answers yet, but what we do know is that quantum mechanics has changed the way we think about time, introducing a whole new layer of complexity and possibility. It's a strange world full of uncertainty and paradoxes, but it's also incredibly fascinating. Quantum mechanics may seem strange, but its implications for time travel are even stranger. As we continue to probe the quantum realm, who knows what other surprises we may uncover about the nature of time and the universe itself. Imagine going back in time and preventing your own birth. Impossible, right? Well, this seemingly impossible scenario is what's known as the grandfather paradox, a classic thought experiment that has been the subject of many a philosophical debate. It's named after the idea that if a person were to travel back in time and accidentally kill their own grandfather before he had any children, then that person would never have been born. But if they were never born, how could they have travelled back in time in the first place to kill their grandfather? This creates a paradox, a situation where the cause and effect can't both be true. This paradox isn't just an interesting thought experiment, it's a fundamental challenge to the concept of time travel. How can we reconcile the idea of changing the past with our basic understanding of cause and effect, also known as causality? If the past is changeable, then causality as we understand it breaks down, and the universe becomes a very strange place indeed. But don't despair, time travel enthusiasts. Some physicists and philosophers have proposed solutions to this paradox. One of the most popular is the many worlds interpretation of quantum mechanics. This theory suggests that for every possible outcome of an event, there's a separate universe. In the case of our time traveler, when they go back and kill their grandfather, they're actually creating a new universe in which they were never born. But in the original universe, their grandfather is alive and well, and they exist as normal. Another possible solution to the grandfather paradox lies in the concept of self-consistency. This idea proposes that the universe somehow conspires to preserve causality and prevent paradoxes from occurring. So if our time traveler tries to kill their grandfather, something will always prevent it from happening. Maybe their gun jams, or they miss their shot, or their grandfather just happened to be wearing a bulletproof vest that day. The universe, in effect, protects itself from paradoxes. So where does this leave us? Well, we're still a long way from understanding the true nature of time, and even further from building our own time machines. But these paradoxes and potential solutions provide valuable food for thought. They push us to question our understanding of the universe and encourage us to explore new ideas and theories. Whether or not we'll ever be able to hop in a DeLorean and travel back to the past remains to be seen. Paradoxes may seem like roadblocks to time travel, but they also provide intriguing paths to new understanding. What if we told you that scientists are testing the boundaries of time right now? Indeed, our understanding of time, once considered constant and unchangeable, is now being challenged and probed in ways that would make even Einstein marvel. In the world of experimental physics, the Large Hadron Collider, or LHC, is a name that rings loud. This behemoth of an experiment, the world's largest and most powerful particle accelerator, is not just probing the fundamental structure of the universe, but also investigating particles that move in ways suggestive of time reversal. So, what does this mean? Well, some particles produced in the LHC, like the B meson, have been observed to decay in a way that doesn't just disregard the arrow of time, but seems to reverse it. In other words, these particles behave as if they're moving backwards in time. It's like watching a shattered vase pull itself together and jump back onto a table. And while this doesn't mean we'll be sending messages to our past selves anytime soon, it does hint at a universe where time is more flexible than we might have imagined. But the intrigue doesn't end there. Another fascinating area of research is quantum entanglement, a phenomenon where particles become intertwined in such a way that the state of one instantly affects the other, no matter the distance. It's a concept so strange that Einstein himself called it spooky action at a distance. Now you're probably wondering what this has to do with time travel. Well, some scientists believe that quantum entanglement might hold the key to understanding and perhaps even achieving time travel. It's a bold claim for sure, but if quantum entanglement can defy the limits of space, who's to say it can't also defy the limits of time? Of course, it's important to remember that we're in the realm of cutting-edge science here. These experiments are pushing the boundaries of what we know and understand. They're not definitive proof of time travel, but rather tantalizing hints that there's more to time than meets the eye. They're the starting points of new questions, new theories, and maybe, just maybe, new realities. Yet amidst all this mind-bending science, it's essential not to lose sight of the bigger picture. Time travel, as we understand it, remains a theoretical possibility. There are still countless questions to answer, paradoxes to solve, and laws of physics to reconcile. It's a puzzle that might take decades, centuries, or even millennia to solve, if it can be solved at all. But isn't that what makes it so exciting? The chase, the discovery, the thrill of uncovering the universe's deepest secrets, one experiment at a time. It's a journey that tests the very limits of human curiosity and ingenuity. While we may not be packing for a trip to the past just yet, the science of time travel is more than a flight of fancy. It's a testament to our unending quest for knowledge, a beacon of what's possible when we dare to ask, what if? From H.G. Wells to Back to the Future, time travel has captured our imagination. It has been a staple of science fiction for over a century, serving as a vehicle for exploring our deepest fears and highest hopes. In stories, we've seen time machines, magical artifacts and wormholes transport characters to other times, allowing them to change history or predict the future. But what if time travel could move from the silver screen into the scientific laboratory? Today, this whimsical notion is becoming a serious scientific inquiry. Thanks to the revolutionary ideas of Albert Einstein, the strange world of quantum mechanics, and the fascinating concept of wormholes, the boundaries between fiction and reality are blurring. Einstein's theory of relativity gave us a new understanding of time, demonstrating that it isn't a constant, but something that can be stretched and compressed. This laid the groundwork for the concept of time travel. Meanwhile, quantum mechanics has shown us that particles can be influenced by future events, suggesting a non-linear nature of time. And let's not forget about wormholes, those hypothetical tunnels in the fabric of spacetime. If they exist, and if we could stabilize them, they could serve as shortcuts across vast distances and times. Yet, as tantalizing as these ideas are, we must remember that they come with significant challenges and unknowns. Theoretical possibilities are one thing, practical realities are another. Then there's the ever-present shadow of the grandfather paradox, a thought experiment that questions the very nature of causality. Philosophers and physicists alike are striving to resolve this conundrum, exploring theories like the many-worlds interpretation that allows for paradox-free time travel. The quest to understand time, to unravel its mysteries, and to possibly manipulate it continues unabated. From the Large Hadron Collider, probing particles that seem to reverse time, to studies into quantum entanglement, we are pushing the limits of our understanding. Time travel remains a theoretical possibility, but the journey to understand it continues to inspire us. And of course, don't forget to subscribe for more content that stretches the limits of our everyday reality. Hit that subscribe button. Until the next time, goodbye.